Hello, welcome to the tutorial, and here I will introduce the T3 class in the CERN root because it's a very important character in this analysis framework here. As you know, root is designed for analyze a very big data here. For example, maybe 2 terabyte or 100 gigabyte for just 1 hour data. So it has some library or class or tool to handle this big chunk of data. Um, so here, let's go into the very beginning of the T root here. All right. So root like a T file, sorry, T tree class like a T file class is like a container, and you can store a sort of thing here. But the T tree is something has organized. So in order to that you understand how it work, the best way is just demonstrate examples. So first of all, I go inside to the root here by the command root. Now I create a T tree object. I call it T here. Then as what we discussed in the T file class, you can put in a key here. That means when you open the file that you save, you can use the key to access the tree that you just saving it. So in this case, I use the same name. The object name is T, the key name is T, just for easy to memorize. So you don't need to recreate a new name here. So the first thing is the key name. Second thing is the title. So if you don't know what's the structure of the object, still you can use the same technique, use a tab here. So it will give you a lot of information like the name is key here. So I type T here. So then, is title is a stream. So let me type in a simple tree. Now there is something split level you don't need to know right now. Its default value is 99. So hit enter. So you create a tree here. So you can use some command like print to see the tree you just created. So now it's nothing there. That's normal here. Um, Alright, so you create a tree. Now you want to fill some variable in it or fill some data or entries. In this tutorial, I will focus on how to write a tree. And the next tutorial will be how to read a tree and do some analysis like make a cut. Okay, so let's step by step. So now it's a very easy example. Suppose you have three brothers, that's A, B, and C here, and your mom would distribute $100 every week for three of them. So you want to record the money for that's distributed each the three brothers every week here. So let's suppose you create variable money A for brother A, money B for brother B, money C for brother C here. Okay, so in order to save time, I just copy it and paste it. Okay, so you declare three variable, and that's is the integer type here. Just suppose the money is all integer here. Now you want to link the variable to the tree, a tree. So in the root terminology, the structure of a tree can a little bit uh, hard to understand, but so right now I just give you a very simple idea. So the first way to link a variable in a tree, you can create 3 branches, and each branch has just one leaf. That's mean variable. So it's just like this branch one is corresponding to a leaf, and this leaf will just link to the variable money A. Then second branch, there's one leaf only. The leaf link to money B, so as the branch C here. And also you all can have the structure like a branch, but 3 leaves. And we will discuss later because we have to use some other things to store in it, like structure or a class, so this will be a little bit difficult. So in order to just get into the understanding of how to use root, I will focus on this. Um, there's just 3 branches, and each branch has one leaf as a starting point here. So now we just create a variable. Now we have to link. So in order to link the variable into a tree is quite easy. So you use the method in a T tree called branch. The branch is something you can uh, link the variable and its branch. You either create or um, to read something. You will know that later. So the first thing you can use tab to see there is a lot of option. Uh, so here I just tell you the easiest one. So first thing is the name of that branch. Okay, this here. So the first one, I want to link the first branch as a variable money A here. So I call this branch is M. A is means money for A. And this branch, I want to link the variable the money A. So I type money A. But remember, you have to use address. To get the variable address, you have to use this symbol, M symbol here. So you get that. Now you link the address, and you have to tell what the type of that variable is, because you just link the address first. So you can have the branch. This is the branch here. MA is branch, and you link to a memory here, and then you have the option, a lot of option here. Then I think I use the leaf list. So here is the format. So you have left. So that means the name, type in the money A, and this is the integer because I use the integer here. So here I hit enter. So I create a branch. The branch is the name of branch is MA, and it has one leaf called money A here, and the type is I, and this a branch or the branch has a leaf here linked to a variable of money A here. So we can type in print again. Alright, so you see you have branch, a new branch here called MA, and the leaf of it is money A, and the type is integer. And you don't have any entry yet because we just link, we haven't filled any data. Another option you can print is to say tab only. That give you just the branch name. So now we just have one branch here. Okay, the tree is T, the key is T, and the title is a simple tree, and one branch here. So we do the same thing for another 2 brothers. So code is a branch MB and link it to the variable money underscore V with the address, and the code leave as money V, and the type is integer. So I copy this, then I pass it here. Alright. So now what we already did is we declare a variable here, we declare a tree here, and we make a connection with them. All right. So right now I change the the variable. Let's I got $100. So I distribute the brother A $10, brother B $30, and brother C $60. Okay. So you can see what I have is I got $10 for my for brother A here. So now I will fill this to the tree. I call the fill. T is the object name for the T tree object, and it has several methods. I use the fill method to to fill the variable from the memory into the tree. So I type fill. Okay. So what happened is you type print. So you get one entry here, one here. Okay. So you want to see what inside that, you can use scan. So now I type all of them here. You see 10, 30, 60 here. And for right now, you just skip this part. It just tell you something, but it's not really precise. If you want to really precise, you can have, because you call the leaf is money underscore A. So in order to scan a tree, you can scan this money A, column money dash B. So you see the 10 and 30 here. So why not make more entries here? So we change the variable. So next week, the second week, the A got $20, B got $30, and brother C got $50, and we record it by fill the method and fill the data in the tree. So we do the same thing. Let's see what's different. Alright, so we have the first entry, that is the 10, 30, 60, and the second entry is 20, 30, 50 here. So I think you got the idea. So we do it one more. Okay, we use scan to scan all the leaf by the this leaf is from designed from us here. So okay, so you see. All right, so to save the file again, you need a T file. That's a container. You can contain either tree or histogram. So T file, let's just call it F, and it's a example. Let's say 1. Okay, this is example 1, and we want to write out. So we use the recreate options. Okay, so we have the container, so we can use the method write to write the tree into the file. So okay, now we see we have the tree here, the simple tree. Now our test is done, so we can have close is, then we will down here. So but I don't want to close it right now. So the thing we need to review is that first we create a tree, a T tree class by the by this here, this line here, and this is the constructor. We call the key is T, and the title is a simple tree here. Then we create a 3 variable, and each variable will become a branch, and only one leaf in it. By that, we use the branch method. So we call this MA and link to this variable here by the address. Then we define what should be the leaf inside. So it's a money underscore A, and it's the leaf name, and the type is the integer here. So here is some parts of the type you can use. The capital I is assigned So you have positive or negative uh, integer. The I is unsigned here. F is kind of float in a C++ language. D kind of like double is a double precision variable type here. So I think you get some idea about how to use the tree, how to write into the tree. So because this just a very first tutorial about how to write the tree. So I think you will get some useful idea now. Then we will come to more complicated cases. So I think I will stop here and okay. All right. So let's see the example two. In this example, we will discuss how to write an array into a tree here. Okay, so we already discussed just single variable, like just one variable here in example one. So an array is kind of a bunch of same type of variable here. So in this example, suppose we have just two brothers, but uh, brother A have two bank accounts, brother B have three bank accounts. Suppose that this situation. So we can declare an array called A account, and this definition is we declare a array with two elements with it. This start from index 0 and 1, and this all the element with this array is integer type here. The t, the int underscore t is the CERN root convention for the integer type. Normally you just use int, but here you use int underscore t. It means that CERN root want to make sure the data type is independent of the machine. Sometimes the different compiler have different definition or different bytes the usage here. So in this case, we declare two array here. One array is A account, another array is V account. This V account has three elements. Start from index 0, 0, 1, 2, and the bracket 0 here means initiation. The make all element into this array is 0. Alright, so right now the text is to create a tree and make a branch to link this, and another branch to make or link to another array here. So we already create a variable, so now we link it. So let's just do it. So just copy it and paste. Okay. Now we have these two. All right. Good. So to link the array, remember we still use branch. So the branch name is A. The second parameter is the address that you want to link. So we use the A account here. Remember there's no ampersand in front of the array's name because the array in C++ or C language is defined by the first address of that element. So it already an address. It's not the variable. So you don't need ampersand. But here in the example 1, this is not array. It's just an integer data type. So in order to get address, you need this ampersand, operator to get address. But this is array here, array with all element with data type, the integer. So you don't need the address because it's already an address here. So the only difference is you don't need to put a operator, address operator. Then we declare the leave here. So because this A account array has two elements, so we call the bank, the maybe you call okay A from B. The leaf name is you can bank from A or the leaf bank from B. This then you have two elements, so you need to type two here, and each one is integer data type. Okay, so you understand how to link it. Now we just copy and paste it. Okay, very good. So let's see what happened. So let's print it now. All right. So what you see is this is a tree here. Now we don't fill anything, so entry is 0. Now you have the branch called branch A and branch B here because we define A and B here the name, and the leaf is the bank from A is array 2 with 2 element, and each element is an integer data type here. So right now the same thing, we make some data here, and we use fill method to fill it. Now we see what happened. Print. Okay, so with one entry because we just fill once. Okay, so now you can see. Uh, let's see. T scan. Okay, so this is first. The first is row means the entry is the index from 0, and the instance is just like an index in this array here, because this is just two elements, and so you don't have the third element from the A from the A account array here. Okay, so here you see this 999 999 is from the B here. All right. So in order to understand, we fill another one to see what happened. All right. So again, T field. So now we see what happened by T scan to scan through the entry. So you see this is the first entry here. The second entry is here. So we see this is the A account first element. This is A account second available element here. So we successful link the array to a branch, and the only difference is that you don't need to have ampersand, and you need to put it into the size of it. All right. So I think you got an idea. Now we will go to another example. So I think I will stop here for a moment. Okay. Okay, so let's go into the example 3 here. So in example 3, we'll discuss the situation to fill a tree with an array, but now array is not the fixed size. That means the first entry might have the array with two elements, but then the second entry would mean maybe five elements within this array. And every time the size of the array will change. Okay, so think about something like you have um, energy of the particle you want to record, but somehow the first entry may be two particle coming, so you have energy with the two element, with the array of energy of two element here. But next time you have four particle coming, so you have an array of energy that's four element. So root can have a very nice way to handle this situation. So the thing is that you need to link the size with a variable in that branch here. So let's step by step here. So first one is still we have to declare a tree. That's very easy. That's Just copy and paste it. So the tree called T here, and title is a tree. Okay, very simple. So right now we declare uh, an integer. This is the maximum size of the array. For example, we think about the particle coming is always less than 100. So you have to declare a large size, very large size of array first. We call this energy, and this maximum, the maximum size is 100 here. So this is necessary because, okay, you will notice later. So then we declare integer called n here. That is the how many particles come in at a certain time. For example, n could be 1 for one particle coming, or 2 means two particles coming here. So if two particles come in, we want to record two energy data for this two particle here. So the first thing we need to do is create a branch. That means how many particles come in. That means the size of the array here. So we link this n here. We create a branch. We name the branch's size and link the variable n here with the ampersand here. This is address. Then we call this leave n as integer data type here. So this is the necessary step because we want to create an array with variables. With the size could be variable, could be varying. So we need to let root know how we vary by create a branch here. So we know this is we create a leaf called n here. So we can let the range know we want the size is n here. So we create a branch here called energy, and we want to link array that's its energy. So we don't, because this is array, we don't need to use the and operator here. Then we call the leaf name is particle energy, and with the array size that can vary, but according to the leaf here, and each one is integer. Okay, so we copy and paste it. Very good. So right now we fix it. We already link the array with another branch. So let's see what happened here by print. So you have tree, and the first array is size, and leaf is, and here, sorry, first branch is size. The second branch is called energy, and the leaf name is particle energy. The size will corresponding to this guy here. All right. So let's do it. Okay. So for example, at the first entry, we just have one particle coming, and energy of that one is 9 here. So we use the T field method to fill it. Okay, good. So let's see what happened. Use print. Alright, so we have one entry here. So what we can do is to use, okay, like scan method. This is n is the how many particle come in. This is energy, and there's some option the column, the size of column you want to show here. So you see the first entry just have one particle coming in, and its energy is 9 here. So let's fill more. So now you have two particles coming, and one energy is 11. The second one is 111. Okay, so you fill it. Then let's see what happened. So now the first one is The same thing here. This is first entry, but the second entry you have two. You have two particle coming here. Now, if you have three particle coming, let's fill it. Okay, very good. So right now you have three instances because you have three particle coming. So it's work. So we already link three. Sorry, we link a variable array that the size can vary to a tree. So I think now you get some understanding how to use the root. So the next topic would be a little bit more difficult. This is the structure, okay? So I think I'll pause here